we're back. So just in case you haven't been able to get a printout packet when you came in maybe a week or two ago to get your binder, or you didn't get your binder and you didn't get the packet, this lab, I'd like you to try to work on the aspects of it that don't require drawing. Try to answer some questions that aren't related to the drawings. You know, if we are actually coming back this year with whatever time that is left, I will provide you the printouts for these so you can complete the drawings on them. But for the time being, I'm going to review this as if you have the document in front of you, and if you don't, it's going to be okay. We'll work something out. So today's pre-lab is going to be on weather patterns. All right, so here's a basic introduction that you should read through. Give yourself a moment to take pause, and you can read this. Afterwards, our focus will be to use multiple field maps to identify patterns to help us predict the weather. There's some vocabulary I'd like you to work through. All right, so our first map, map A. We are looking purely at temperature patterns on this map. The instructions for map A will be found here on the next page, procedure map A. On map A, use a pencil to lightly draw isotherms at 10-degree intervals. By 10 degrees, I mean 10 degrees Fahrenheit. That is the interval. Make sure you check carefully to be sure that the isotherms are correct before you darken them in. So when approaching this map to identify which station models will choose to connect our isotherms at a 10-degree Fahrenheit interval, we want to try to pick a number that's easily divided by 10. So if looking through our symbols, we have to first notice what data has been provided to us, and we're also going to have to remind ourselves, where does temperature exist on a station model? So our data exists on our station models at cities. There are names for those cities. Okay? If you got a printed copy, these values are far clearer than the version I have here, which is scanned. When looking for a value to start with, we are going to, again, identify a value of temperature in the location here on our station model. This is not temperature if you're looking at page 13 of your reference tables. This is, again, our code for our temperature. We've been given cloud cover and wind direction, not wind speed. Hard to read this. It says Calgary, Winnipeg. This is Father Point. What I find important is that the temperature is 30 degrees Fahrenheit. So 30 is easily divided by 10. So I'm going to circle my station models that I see with 30 degrees Fahrenheit. My station model circle for where the cloud cover is, that's going to act as my dot to connect my isotherm line. Also, something to keep in mind is that we need to make sure that as we're drawing lines, we extend to the edge of a map if the pattern for that exists. If the pattern indicates that we are closing up shapes, continue to use that pattern. For this one, it does not look like it's going to close up. It's going to travel across the continent. So I'm going to connect my isotherms. Also, realize you might have to make your own dots to find and navigate your way through. It does get a little tricky in this region here. So we have a 40 and a 27 degree Fahrenheit station model here and here. We can assume that 30 exists in between them. So I'm going to connect up my station models with my assumed 30 degree dot. 2734, should have a 30 in here. Let's see, I can't go between 33 and 34, can't go between 33 and 44, between Detroit and, can't read that one, but that's Michigan. All right, so I'm going to transfer maybe up through here. So let's look, 27, 33, yeah, I like this area right here. All right, it looks like it's pretty smooth sailing all the way over to Father Point. So I'm going to continue to connect up my line. All right, so as we look at this, we see we have at least the interconnected station models from here to here. But we have to finish out the map in that we need to extend our ISO line, our isotherm, to each edge of the map. Okay. Now, as you continue this pattern, please keep in mind that it's going to be a 10-degree interval. So if it's 30, then you're going up by 10 degrees Fahrenheit until you exhaust the values on the map. You don't need to go to 110, 120, 130. They don't exist on the map, so you're not going to need to do an isotherm for that. Okay. After you've completed this map, you're going to then start answering the questions. So for those of you that don't have the diagram to create this, what you won't be able to do at the moment, you won't be able to answer 1. You won't be able to answer, actually you'll only be able to not answer number 1 with the map, okay? Question 2, 3, 4, and 5, you will be able to do the calculations or the descriptions. If you get stuck on any of these, please focus on using the access point to give you maybe a first step. Some of this information goes all the way back to using things like gradient, making sure that you use a formula, you fill it in, you simplify and solve with the correct units. Okay, map B. You're going to map the barometric pressure patterns here. So it's the same map, same station models, but you're using a different aspect of the station model to help us predict the weather. So procedure map B. Step 1. On map B, use a pencil to lightly draw isobars. So iso lines again, but we're doing bars of pressure between points of equal atmospheric pressure. Okay. So we're connecting equal station model pressures. Use a 4 millibar interval. Start counting at 1,000 millibars, 0, 0, 0. So you're going to look to find any station model that has 0, 0, 0, and you're going to be connecting them up. Subliminal hint, kids, right here. This is a subliminal hint. Okay? So, continuing by a 4 millibar interval, we're counting up by 4 millibars. That does not mean that you're adding a 4 to the code. You're adding 4 millibars, an already converted value. You're adding that to the correct value of 1,000. So your first pressure you're going to solve by yourself that needs to get connected will be 1,004 millibars. So you're going to need to then convert from 1,004 to a 3-digit code. You have to convert it to 040. So you are referring back several lessons ago to converting codes and pressures. In this case, a reminder, we dropped the 10, got rid of the decimal, and the unit is in the title, so it's already missing from writing, leaving us with 040 as the code. Continue to fill out this chart to help you find all of the correct codes that you will be connecting, for your pressures. Also, in order for you to understand how to answer this without the map, question 1, you will need the map completed. Question 2, you will not. You will just be looking through the map for pressures. 3, you do not need the drawing. 4, you do not need the drawing. 5, you do not need the drawing. 6 and 7, you will not need the drawing. Okay? The drawing is an element unto itself with the question 1 only. Now, when you are using map B, you need to start identifying where those pressures are for the codes you solved. So the first thing we had to do is look and see if there is a 000 anywhere in any of these positions at any of these city stations. I don't see any 000s. Next, we have to start looking for 040. Turns out here's an 040, and that's at. Did they not give me the name of the city there? They didn't give me the name of the city there. Silly. All right, so let's find another 040. We've got Chicago. We've got Detroit. Any other 040s? No, but this is an 017. That's too small. That doesn't work. Turns out that it looks like we're going to have to connect them. So here, I'm going to connect through and around here because 017 and 080, that's a gap. My 040 can fit between 17 and 80. So 40 fits between 17 and 80. If we're just purely talking about the value itself. Okay? I can connect to here. That's safe. I don't see anything that's going to interfere with connecting those. And I'm going to finish that out by connecting here. Okay? So you can see that there's a general pattern to our isobars. Okay? You'll continue this until you exhaust all of those codes. You may start to see that there are 2 pressure regions. That's going to be very important for the other, went the wrong way. That's going to be very important for your procedures in that you have to continue to make sure that your isobars are correct, but then you must label. And number 3, label the centers of high and low pressure areas using a capital H and a capital L respectively on the map. So you're going to be placing an H in the center of your high pressure. You'll be placing an L, capital L, inside the center of your low pressure isobars. Alright, so map C, surface wind patterns. Similar idea, we're using the same map, same station models. Let's take a look at the procedure C for map C. Alright, so at each station model, extend the shaft of the wind arrow through the station model and draw the head of an arrow to show the direction the wind is blowing to. Because we've been taught that these station models, the shaft is telling us the direction the wind is coming from. In this case, in our lab, are going to be showing the direction the wind's blowing to help us see that rotation around our lows and the rotation around our high pressures. Okay? Lastly, after doing all of those, you're going to draw one large circular arrow, either clockwise or counterclockwise, around your high pressure and your low pressure centers. So you will need your low pressure and your high pressure centers from the previous map. You're going to locate them on map C, place them there, so that you can complete procedure number 2. If you don't have the map, number 1, you're not going to be able to do number 1. You can describe this based on the right-hand rule that we did. So you can do number 2. You can do number 3. You can do number 4. And you can do number 5 using the right-hand rule to solve these. All right. Map D, precipitation patterns. Okay. So let's go see what procedure map D is. So instead of using a dot symbol on the station model, which represents rain. As a reminder, the dot represents rain. They've instead placed a capital R inside of the cloud circle, the cloud cover circle. What we're going to do is we're going to draw a line around the areas on the map where precipitation is occurring. So that if we know that every station model there's an R, that area, so the area inside all of those connected is where it's raining. You're going to lightly shade in that area where the precipitation occurs. Last, after you find where all that precipitation is, I want you to label, just like we have in our notes, where a CP, continental polar, and an MT exist on the map. So let's go to the map. I'm going to help you find all the R's. Missing any? Nope, that should be all of them. So this is not going to connect like a zigzag line. There's going to be some shape to it. Okay? I'm not going to continue this, but this gives you kind of a good indication of where it's going. I'm going to let you know it sort of looks like an upside down capital letter. That's your hint. After this is done, you lightly shade it in. And you're going to label where our air masses can be found. A CP and an MT. All right, so where is precipitation occurring relative to a continental polar maritime tropical air mass on the map? You can still use your notes to solve this. The map could help accentuate that answer, give you more detail to make a better decision, but there is plenty of resources available to you in your notes to determine this answer here. This one talks about how clouds form. We have plenty of notes on that. We also can compare and contrast low pressures and high pressures, okay, when it comes to cloud formation. Last but not least, Map E, Synoptic weather map. So now we're going to be adding some of the other maps onto this map. Okay. Let's look at the instructions. So procedure map E, refer to maps B, C, D. You're going to copy onto this map your isobars, general wind patterns. So you're only going to be doing your high and low with either a large clockwise or a large counterclockwise for your general wind pattern. Okay? And the area of precipitation on the map from the last one. That information, you are then going to place a warm front and a cold front that stem out of your low pressure, like we saw in our practice notes. And you will have to provide the correct symbols for that to represent where it's raining and what type of air masses are behind the front. 1, 2, 3, 4, and 5 can all be done without the map. Lastly, these are breaking down in even more detail the conditions for high pressure and the low pressure system. So if you need to at any point, feel free to rewind, rewatch, add some questions underneath this video, send me some messages. Most of all, take your time, use the access points, and if anything, you can work together a little bit. I'm okay with that. I know it's a big lab. As I said, if you don't have the physical lab in front of you because you weren't able to pick up those materials, don't worry, we'll make it work. Until next time, check that out. Do a good job. Bye.